Hi, this lesson is on right triangle trigonometry or applications of right triangles. So let's start with this warm-up. And this warm-up is asking you to solve for x, y, and z. So what I see is several special right triangles. And so if this is a 45, 45, 90 already, we know that that's 45 here, which means this angle here must be 45 degrees. If that's the case, then both of these sides are congruent. And we can say that's 4 root 3. Now we're using our special right triangles in that if you have a right triangle that's isosceles and you have this is x, this value is x root 2. So if this is my x and that's x, so this will be x root 2. So it'd be 4 root 3 root 2, which makes that actually 4 root 6. So let me erase that. So this will be 4 root 6. Then if this is a right triangle here, and this right here is parallel to that, that means that this is also right, because parallel lines form with a transversal perpendicular. These are supplementary, so there I have another 45-degree angle. And if that's 45, this is also 45 degrees, and that makes this side here congruent to this side here, so that makes y also 4 root 6. And again, so that's x root 2, so this would be 4 root 6 root 2, or 4 root 12. And actually on 4 root 12, I can reduce that. So let's do that on the side. So 4 root 12 is equal to 4 times root 4 times root 3. So root 4 is 2, so that's 4 times 2 times root 3, so 8 root 3. So this side right here is 8 root 3. Okay. Now across from the 60-degree angle is a root 3. So we usually, if you have a 30, 60, 90 right triangle, and across from the 30-degree is a. Across from the 60 is a root 3, and across from the 90 is twice what's across from the 30, so that'd be 2a. So if across from the 60 is what we call a root 3, I'm going to set this equal to a root 3 so that I can solve for a. So that equals 4 root 6, and so therefore I'm going to get a by itself, and I'm going to divide by root 3 on both sides, divide by root 3. And so I have, let me erase this part right here. And so I have a is equal to 4. Now remember, roots can divide out roots. So root 6 and root 3 are going to become root 2. So a is equal to 4 root 2. So across from the 60 is a root 3, but across from the 30, this is going to be 4 root 2. And then across from the 90 is twice what's across from the 30. So if this is 4 root 2, I'm going to multiply that by 2. And so W is going to equal 8 root 2. Okay. So you're going to need a calculator for this lesson because this entire lesson is on applications of right triangles. So the first thing we're going to practice is trying to find this angle right here. So what we have is the previous lesson, we learned about sine, cosine, and tangent. And we learned that this little mnemonic, mnemonic is something that helps you learn something or remember it. So, ka, toa. And so what we learned with this is that sine of an angle is equal to the opposite side over the hypotenuse. We learned also that cosine of an angle, and see there's the cosine, is equal to adjacent over the hypotenuse. So adjacent side over the hypotenuse. And then we also learned that tangent of an angle is equal to the opposite side over the adjacent side. So that being said, what I have here is I have this angle that I need to find. And that's the opposite side. Okay, this is the adjacent side, and this is my hypotenuse. Now, I don't have any information on the adjacent side, so therefore, I'm not going to use anything that has to do with adjacent. So meaning, I'm not going to use cosine, and I'm not going to use tangent, but I am going to use sine. because sine of the angle, and in this case they're using x, so sine of x is equal to the opposite side over the hypotenuse, which is 7.8. And so in order to isolate the x, we're going to take the sine and we're going to move it to the other side. The act of doing that is called arcsine. It's an inverse. So you say arcsine of 5 over 7.8. Now, some people might get confused on why that is. That's an inverse. When you move this sine value over to the other side, that's an inverse. It's sort of like, let's say I had x plus 3 equals 10, all right? If I were to take 3, subtract 3 from both sides, negative 3 is the inverse of plus 3. In order to isolate the x, to get the x by itself, I need to move this 3 to the other side. The act of doing that, opposite value here, is called an inverse value. So that's what I'm doing here, is I'm taking my sine function and I'm moving it to the other side. In doing that, it becomes its inverse. So some people will say the inverse of sine, but the correct way to say that is arcsine of 5 over 7.8. And so you will need a calculator for this, because on your calculator, now I have this one right here. And so you're going to make sure that you're in degree mode for this value. And so I'm going to go arcsine. And so you should try to, okay, so new document. And so let's see, arcsine. So I'm going to take trig function, arcsine, and you only use arcsine, so 5 divided by 7.8. The only time you use arcsine is to actually find an angle. So otherwise, you're just using sine, cosine, and tangent to find the lengths of the sides, like a ratio. So this is going to be 39.87 degrees. So I'm going to round to the nearest hundredth. So that's angle X, which is right here. And a lot of times you're going to have to solve for both angles. So just know that if one of your angles is 39.87, all you have to do is subtract 90 and go 90 minus 39.87, and that's going to give you 50.13. So this other angle, if they were asking me for that, is 50.13 degrees, because you just remember, you just take 90 degrees because this angle and this angle are going to add up to 90. And you just say 90 minus whatever your X value was, okay? So just a couple of things. We were just talking about this. If you're finding sine of an angle, you're going to get the lengths of the sides. But anytime you find the arc sine, you're always going to try to find an angle. You're always finding an angle. But if you start off with sine of an angle, you're going to get the output is a ratio of two sides, like, 2/5 or something like that. So in solving applications of right triangle, okay, there's some tips. First of all, you always need a right triangle in order to use a trig function. You are going to make it into an equation, and you are going to have a solution. The best case scenario is always to try to make a diagram. So a couple of key words that we talked about in class, and we talked about road grade. Road grade, if this is a 12% grade, that's 12%. Now, remember what percent means? Percent is the same thing as 1 over 100, okay? So if this is 12%, that's 12 times 1 over 100, or 12 over 100, which is my rise over my run. So really, this is saying 12 over 100. My altitude is this height, okay? And that's always going to be perpendicular. The angle of elevation is always based on a horizontal, okay? So an angle of elevation is based on the horizontal, and it's the looking up. That value in here, that's the angle of elevation. So if I have a horizontal and I'm looking up, this angle right here, so this, they said 25 degrees, so that would be 25 degrees. Now the angle of depression is also always based on a horizontal. Now keep in mind that this angle outside here, that's my angle of depression. So that's 15. But several people could get this confused in that, let's say here's an airplane, okay? and the airplane starts making a descent off of the horizontal, okay? So when the airplane starts making the descent like that, what ends up happening is that's the descent. This angle here is the angle of depression. All right, that's it right there on the outside. So let's say that angle of depression is 15 degrees here, all right? Keep in mind that angle based on my ground, okay, which is also horizontal. This angle here is the same value as this here. So really, realistically, the angle of depression is the same as the angle of elevation, this based on the right triangle. So here we go. We're going to start off with this question. It says, when you are 5 feet away from the base of the Statue of Liberty, you look up, and so you're away from this. So you're at 525 feet away from the base of the Statue of Liberty. You look up at an angle of 25 degrees. So here's 25 degrees, and take a picture. Now, if you are 5 feet tall, so that's how tall you are, how tall is the statue with the pedestal? So they want this height right here. Now, keep in mind that when I'm done, I am going to have to add your feet, how tall you are. So we're going to try to find x. And so what you need to ask yourself is, this is a right triangle here. This is my hypotenuse. I am not trying to find the line of sight. I'm not trying to find that value, this hypotenuse. So therefore, what I have is the opposite sides. This is my opposite side, and I have the adjacent side. So what I'm going to do is I'm going to say, well, tangent, if remember your SOHCAHTOA, tangent is opposite over adjacent. So you're going to say tangent of 25 degrees is equal to the opposite side over the adjacent side. So that's x over 525. And so we're going to cross multiply, and I'm going to finish this down here. So x equals 525 times tangent of 25 degrees. Okay, and so use your calculator, and you're going to multiply those out. Now, keep in mind, you have to make sure you're in degrees. So I'm going to say tangent of 25 degrees, tangent of 25 degrees, and I'm going to multiply that by 525, and I get approximately 200. And when you're saying approximate, because I did round this value right here, I'm going to get approximately 244.8 feet up, okay? And keep in mind that that is x right here, but because you are 5 feet tall, and that's where your eyeballs are, let's say, you're going to take 244.8. So we're going to take 244.8, and we're going to add 5 to that. So now we have 249.8. So that's how tall this statue is, with the pedestal included. So this one is asking me that, it's telling me that there's a ladder that reaches two values here. We have this one reaches up x meters, and this one is reaching up y meters. And so this is with 70 degrees, and this is with 60 degrees. And so this one looks like it's closer up to the wall. Okay, so what the question is how much higher is it? And so I am using the hypotenuse here for both of these. We are using what's called the opposite side for here and the opposite side for here. So you're going to say which one uses the opposite and the hypotenuse. So that's going to be sine of the angle is equal to the opposite side over the hypotenuse. Likewise, I'm going to use the same formula here. We're going to go sine of 60. So sine of 60 degrees is equal to the opposite side over the hypotenuse. So we're going to cross multiply, and we're going to get this times this equals x. So x equals 6 times sine of 70 degrees. And this one is y is equal to 6 times sine of 60 degrees. And so what we're trying to figure out is how much higher is one over the other. So we need to find x, and we need to find y. and then we're going to figure out how much higher one is over the other. So using your calculator again, we're going to make sure, again, that you're in degrees, and we're going to say, well, sine of 70 degrees. So sine of 70 degrees times 6 is 5.64. So this one is 5.64 meters, okay? And then, oh, this says to the nearest tenth. So that'll just be 5.6 meters, okay? And this one will be 6 times, let's see here, we're going to go sine of 60. So sine of 60 degrees. And then we're going to multiply that by 6. And we're going to get 5.2 meters. And so in doing that, one is higher than the other. We're going to take x, and we're going to say 5.6 minus 5.2. And so that's going to be 0.4 meters. And so the one ladder is 0.4 meters higher than the other. And this is just what I did. So this is just a little bit, this is acceptable work. The ladder reaches 0.4 meters higher than, when it's at a 70-degree angle. So the next question, these are more of application problems. It says at a certain type of day, you have an 80-foot tall, so there's my 80-foot tall redwood tree. It casts a shadow of 30 feet. Now, this is the part where people get confused. Where do I put my shadow? Okay, and so keep in mind, so here's my big right triangle, okay, and this comes straight down like this, right? Okay, shadows, everyone, are on the ground, okay, unless you're Peter Pan and you have a shadow on the wall, shadows are on the ground. So if your shadow is 30 feet, that's going to go like that. It's 80 feet tall, so there's 80. And so your job is to figure out what angle is the angle of elevation. So that's the angle right here. So we're going to find theta. Now, we don't have the hypotenuse, and nor did they ask me, let's say, what the line of sight was. So we are not using the hypotenuse. So you have to ask yourself, which trig function? I have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So which one of these does not use the hypotenuse? And if you answered tangent, you're right. So tangent of theta is equal to the opposite side over the adjacent side. So that's going to be 80 over 30. And theta is equal to, remember, move this over to the other side. So that's going to be called arc tangent of 80 divided by 30, which is just 8 divided by 3. And so on your calculator, you're going to say theta. And by the way, if you were given a test or a quiz and you did not have a calculator, or you weren't allowed a calculator, this would be my answer, because that's as far as you can get without a calculator, unless you understand the tangent graph, and then you could probably get a good estimate. So anyway, we're going to say tangent of an angle, and then we have 8 divided by 3. And so this is approximately 69.4. So theta, so my final answer would be theta is approximately 69.4 degrees. And so that would be my answer. The next question says, a kite is flying at an angle of elevation of about 50 degrees. So my kite's flying up at an angle of elevation. So let's see. Let's make a triangle, okay? And let's see here. It says that it has an altitude of 40 meters. So here's 40 meters. They want to know how long the string is. So this is my string here, okay? So we don't know that. Let's see, what do we know? Angle of elevation is 50 degrees. So there's the value here, because that's your looking up value. That's the looking up value. That's your angle of elevation. How long is the kite? Well, we want to find x. So we have the angle. So we're not going to use arc sine or arc cosine or arc tangent, because we have our angle. We know that's 50. That means that's 40 degrees, because remember, those have to add up to be 90. So this is opposite, and this is my hypotenuse. So which one uses the opposite side and the hypotenuse? So if you're thinking sine is opposite over hypotenuse, Cosine, opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent of an angle, is equal to opposite over adjacent. So that means, and I don't want that one because I don't have the adjacent side, and I don't have the adjacent side, so we're going to use sine. So sine of 50 degrees is equal to the opposite side over the hypotenuse. I'm going to cross multiply, and I'm going to get x times whatever sine of 50 degrees is equal to 40. And then I'm going to get x is equal to 40 divided by whatever sine of 50 degrees is. So we're going to say, let's see here, 40 divided by, I'm going to use parentheses on my calculator, sine of 50 degrees. I'm going to close my parentheses. Okay, and approximately 52.2. So x is approximately 52.2, and it looks like it's meters. Okay, so that's about 52.2. So just keep in mind, make sure your 2 units of measurement are matching up. Okay. Says that you have a lighthouse, and the lighthouse is at the top of a cliff. Okay, so let's make a cliff. We have the boat, and then probably something like this. It says a lighthouse at the top of a cliff sights the boat at an angle of depression. Okay, so I love this question. So remember what I said about the angle of depression? They are on the horizontal. So that means that this is my angle of depression. So that means that's 12 degrees, which means this down here is 12 degrees. If the cliff is 50 feet tall, so now it's height there, how far is the boat from the base of the lighthouse? There it is. So we're going to use tangent because I have the opposite and I'm trying to find the adjacent. So we're going to say tangent of 12 degrees is equal to 50 over x. So we go x times tangent of 12 degrees equals 50. And then I'm going to isolate the x, so I'm going to divide by tangent of 12. So I'm going to get 50 divided by tangent of 12 degrees. Okay, so on your calculator, you're going to say 50 divided by, I'm going to use parentheses again. Anytime I use parentheses or dividing, I'm going to use parentheses. Tangent of 1, 2. Be careful that you're not using arctangent, because you only use arctangent or arcsine or arccosine when you're looking for an angle. We are not looking for an angle. We are looking for a side. And so this side turns out to be 235.2 feet, or yeah, looks like we're in feet. So this value is 235.2 feet. Now, a couple of things. You should ask yourself, does this sound reasonable? Okay. And what I'm thinking is this. I'm thinking that, remember, the smallest angle, which is 12, is opposite the smallest side. So 90 minus 12, because this length is 12, is going to be 78. And so this is a much bigger angle. And so that side opposite that should be a lot bigger, and it is. So I'm going to assume that that's correct. For this one right here, we have an airplane approaches an airport at a 5-degree angle of a depression. So again, you would make a graph, okay, and I'm going to make a right triangle here. And remember, your airplane, when it starts approaching, always starts its descent on an angle of depression. So that angle is 5 degrees, which makes this angle down here 5 degrees, okay? The airplane is flying at an altitude of 30,000 feet. Find the horizontal distance. So they want the horizontal distance, that value here. So what I'm going to use is tangent, again, because I'm not using the hypotenuse. So I'm going to say tangent of 5 degrees is equal to the opposite side over the adjacent. So we're going to say 30,000 divided by x. I'm going to cross multiply and go x times tangent of 5 degrees equals 30,000. And so divide out the tangent of 5, I get 30,000 divided by parenthesis tangent of 5 degrees. So let's see, we have 30,000, use your calculator, divided by the quantity, tangent, of 5, and that's approximately, theta, or x, is approximately 342,902. So it's about the ground distance that the plane must travel. It must travel 342,000 feet before it gets to the airport. That's kind of neat. So number 5 says that we have a road that is a 7% grade. Okay, so let's see, here's my car. So I'm going to say, here's my road. And in this case, let's see here, 7% grade. Keep in mind, 7% is the same thing as 7 times 1 over 100, which is 7 over 100. So that's my rise over my run. So my rise over my run here. Now here's the problem here. It says if a car drives 3 miles up the road, okay. So with this is, so far you have, there's 5,280 feet in a mile. And so what you're doing here is you're thinking, well, I need to know how far or how much altitude the car is gained in feet, because this car is going farther than what we're going, because so far the altitude is 7, but in this case, this is going to keep going farther. Okay, and so we need to know how much it's gained. So that's not a very good triangle. Let me try to draw this better. Let me start over with this drawing here. Basically, again, so what we have is this value here. So you've got your rise over your run, which is 100. Okay, and then what you have is the car is going further than what you have. And so we need to know how much altitude it's gained. So from here to here is 7, but we want this value here. So in order to find that altitude, okay, first of all, we need this angle in here. So to find that angle right there, okay, to find that angle, what we're going to do is we're going to do tangent. We're going to use tangent because we have opposite over adjacent. And so we're going to say, well, tangent of the angle is equal to 7 opposite over adjacent, which is 100. So theta is equal to arctangent of 7 over 100. And when you do that, you get theta is approximately 4 degrees. So what we have here is this value right now is 4, about 4 degrees. So once we have that value, okay, once we have that value, now we have to figure out, well, first of all, we know that the car drove 3 miles. And so this was in the direction here that it's driven 3 miles. And we know that, and we know that 3 times 5,280 times 3 is approximately, what is that? 15,840. So 15,840 feet. Okay, so that's this length here, 15,840 feet, because if they went a total of 3 miles, that's 15,840 feet. So to find x, we're going to use what? Opposite, because there's my right angle, opposite over hypotenuse. So I'm going to say sine of 4 degrees is equal to x over 15,840. I'm going to cross multiply. I'm going to get x equals 15,840 times sine of 4 degrees. So x is approximately 1104. So 1104. Now, feet up. But if this is the value here, 1104, the question said not what's the altitude, it said how much has the altitude gained. So we would take 1104 and subtract 7. So borrow, that's 9. And so what is that going to be? 7, 9, and I lost my numbers. 9. Okay, so I think that's it. Okay. Okay, so let me just check. 1104. Oh, that's not right. Let me fix that. That's 111097. There we go. So that should do it. Okay, so number 6. We have a snowboarder. A snowboarder rides 2 kilometers down a steep slope. Okay, so he's riding his snowboard down the steep slope. Okay, and it says from the top of a peak to its base. If the peak is about 800 meters, so it's 800 meters tall, so that's 800 meters tall. What is the angle of elevation? So we want this value right here. A couple of things for this problem you do need to know. Okay, so you do need to know that 1 kilometer is equal to 1,000 meters. So if they went 2 kilometers, then they're at 2,000 meters. So this value right here is 2,000 meters. We need to find this angle of elevation. This is a right angle. So we're going to use opposite and hypotenuse. So we're going to say sine. So I'm going to say sine of theta is equal to 800 over 2,000. And my job is to find theta because I'm trying to find the angle of elevation, which means that I need to take sine and move it to the other side. So that's going to give me theta equals arc sine. That's the inverse of 800 divided by 2,000, which is 0.4. So I actually could just use that. Theta is equal to arc sine of 0.4. So now I'm going to use my calculator, and using my calculator, arc sine, I'm going to get approximately 23.5 degrees. Okay, so that's my angle of elevation. Okay, number 7 says you and a friend have climbed to the top of 2 trees. The trees are 10 feet apart. So we have this length here and this length here. These are 10 feet apart. Your friend sits at the top of the shorter tree. Okay, so this is the shorter tree here, and then here's your friend. All right, there's your friend. And that tree is 25 feet tall. If your friend looks up at you, and based on my horizontal, my friend's looking up at me and probably looking at me at the top of this other tree, an angle of 27 degrees, how tall is the tree? So we know that, we're trying to find that, okay? And that angle is 27 degrees. There's another right angle here. And this is your view at the top of the tree. So we already know that this length here is 25. Okay, we're going to have to add that at some point. We know this length is 10. We need to find this length right here. So we have opposite and adjacent. So we're going to say tangent of 27 degrees is equal to opposite over adjacent. So x is equal to 10 times tangent of 27. So x is approximately, you're going to use your calculator, tangent of 27 degrees. Cool. Times 10 is 5.095, so about 5.1. So it's approximately 5.1. And so this value right here is about 5.1. So keep in mind that I need to take my 25 foot tree, and then I'm going to add another 5.1 feet to that. And so now I'm at 30.1. So that's about how tall it is. Okay. How tall is your tree? The tree is about 30 feet tall. All right, I think that's it. So I hope that helped, and let me know if you need any additional assistance and you come in for help. Thanks.